Okay, so here we have the triangle. We got to solve it. What do we know? We know cosine law, okay? In its two forms, a squared is b squared plus c squared minus 2bc cosine a. Part you need to make sure is this angle, and little a, that's the same letter, okay? This is the angle opposite this little side a. In terms of an angle, if we're solving that for cosine of a, okay, we have b squared plus c squared minus a squared all over 2bc. Okay, and we also know sine law. Hopefully we don't need to write that down. Okay, we're always looking for the opposites, right? Ratios of two sides. What are we going to use to solve this triangle? Do I want to solve for a length, or do I want to solve for an angle? Yeah, I have my three sides, right? I have my three lengths there. So this is what I want to use. So let's solve. I have this for angle A. You know what? So let's solve for angle A. So the cosine of A is, which ones have to be B and C? Which one has to be A? That's what you have to be clear of. Okay? Let's make that a little simpler. One has to be A. B and C, it doesn't matter. Which one's A here? Cross from A, that has to be little a, right? Okay, so B and C, doesn't matter which order you put that in. 13 squared plus 21 squared minus 11 squared all over 2 times 13 times 21. Okay, if you do this properly, you can just put that in your calculator in one step. Make sure it's in degrees. Okay, 13 squared plus 21 squared minus 11 squared equals, you have to hit equals if you don't use brackets or you get the wrong answer, right? Divided by 2 divided by 13 divided by 21. Those are all on the bottom. You got to divide each one. That's what cosine A is, 0.8956. Doesn't look like an angle. What button do we have to push if I don't know the angle? Inverse cosine of that 0.8956, or this calculator, I can just put in the answer. Makes it kind of nice. Don't have to write it down. 26.4 degrees. Okay? So angle A is 26.4 degrees. Okay, that's one angle. I have to solve this thing, right? So I have to get the other two angles. Once I have two angles, obviously I don't probably want to use sine law or cosine law. I just want to subtract them from 180. But what angle do I want to get next? Well, it's your choice. Okay, let's try for angle B. Now let's do angle B. Okay, I'm going to use cosine law. Do you have to use cosine law to get B? You can use sine law too. Let's do it both. Okay, first let's use cosine law. So, let me do this in red. So the cosine of angle B is, okay, I can have 11 and 13, doesn't matter where, but you have to have, this is the opposite, that has to go minus on the end, right? So that's the side opposite B. Okay, these guys have to be opposite. All over 2 times 13 times 11, okay? If you put that in your calculator, I'm not going to do it, and take the inverse cosine of it, we will get 121.9 degrees. Okay? Does it look reasonable for our picture? Yeah, you should always check, right? I don't know, this isn't totally accurate, but it doesn't look bad. 13 is definitely longer than 11. 21 is definitely longer than 13. Okay, I didn't take a protractor and measure this thing, but it looks okay. That's definitely obtuse, right? Okay, so let's go with it. What happens if we try to solve for angle B using sine law? Okay, what do I want to do? I want to use this ratio. I got a side and angle opposite it, and I have the side opposite B, so I can use sine law to solve for that. Okay, the sine of B over 21 is the same ratio as the sine of 26.4 over 11. Okay, it's the same ratio. How do I solve for that? Let's get rid of 21. You can think cross multiply, but all I got to do is times 21 to both sides, and it's gone. Okay, so the sine of B is, what is sine 26.4 times 21 divided by 11 is that 0.8488. 0.8488. So angle B, have to take the inverse sine of that. Inverse sine of the answer is 58.1. Huh. Is that what I got before? No. Does that look like 58 degrees here for B? Is that a little ambiguous? Did I get a double meaning? What did we do yesterday? Remember, the sine of some angle is the same as the sine of 180 minus that angle. Your calculator doesn't know this angle is obtuse. It thinks it's acute, so that's the number it's going to get. If you're sure that's an obtuse angle, you have to find the other angle. Okay? This angle is obtuse. It must be 180 minus 58.1. What's 180 minus 58.1? Oh, look, 121.9. That's what we got with cosine law, wasn't it? Okay? 121.9. Okay? That's why we call it ambiguous sine law. It's because we're not sure if it's the obtuse angle or the acute angle. You need to look at your picture. And if you're not doing a picture, then you're probably going to get it wrong, because you won't know if that's an obtuse angle or an acute angle. Okay? Ambiguous. It has double meaning. You need to know. All right? If you use cosine law, there is no ambiguous cosine law. If you do that every time, you'll always get the right answer. It's just an ambiguous sine law when you use sine law. Okay? But sometimes you're stuck. You have to use sine law right off the bat. Okay? You just have to keep this in mind. That's it. Okay? So there's not too many questions where it's going to do this. And like I say, I don't know. There's lots of ways to solve a triangle. If you're just using cosine law, then you're not going to have an issue. But some of you, for some of these, might use sine law, and you'll get an answer that is an acute angle, not the obtuse one. So of course it's going to be wrong. Okay? So this, like I said, it's a lot like last chapter. We're just using sine law, cosine law.